Hello everyone, today I will show you how to obtain the contribution of modes into the total response obtained from response spectrum analysis. I have shown you previously how to compute the response of each mode in this Excel sheet as shown here. Those are the response of each mode, and the final answer is just a combination of these response using a combination rule like SRSS or CQC. Today I will show you how to do these steps inside ETABS without the need to go into all of these details here. And I will start first by reminding you about the modal amplitude, which is equal to participation factor multiplied by spectral displacement. If we go to ETABS and we obtain the participation factor, we will find that the participation factor computed here is different from the one provided by ETABS. I have extracted this table, which is the modal participation factor, and as shown here, the first mode have a participation factor equal 174, while I have obtained a value of 1.531, and they are not the same as shown here. This is because the participation factor is dependent on the mode shapes, or how the mode shapes are normalized. For example, if we go to this Microsoft Word, as shown here, this is the equation of the participation factor. Therefore, they are dependent on the mode shape, how the mode shape are normalized. This is one thing I want you to notice. And the second thing I want you to notice is that the denominator here is not used in ETABS because they normalized the mode shape in such a way that this denominator here will provide a value equal to 1. Therefore, no need to use this term, because it's equal to 1 in ETABS software. This is due to normalization of modes. This is what I'm trying to say. Therefore, they just use the first term. And as shown in this equation, we need to use the modal amplitude, which is equal to participation factor multiplied by the spectral displacement in the equation used for computing story displacement, and also this term is used for computing the forces of the structure. Therefore, we need the modal amplitude. And we can obtain the modal amplitude as shown in this figure. We can go to response spectrum model info, and this is here the modal amplitude due to a force applied in the x direction. Okay, going to ETABS, I will obtain the modal amplitude from display, show tables, and please check the last option here, response spectrum model info, and make sure about you have selected the response spectrum analysis load cases, and OK. I will copy these values to Excel. In this Excel, I have prepared this sheet, model contribution. Let's copy the values to here. I will select first the x direction. The acceleration obtained from the spectrum, and here the modal amplitude. And now for the y direction, just do the same. Okay, those are the modal amplitude, which are equal to the participation factor multiplied by the spectral displacement for the response spectrum load cases in the x and in the y direction. Please note that, for example, the mode number 1 is translation in the x direction. Here I have copied the table of mass participation. You can check it also by using this table. For example, the second mode is a rotational mode. The third one is translational mode in the y direction. Therefore, we need to use this value here. Of course, you can take the effect of the rotational mode in the y direction. You can also use this modal amplitude. We need here mode number 4, And 6, I will just use the first 3 translational mode in each direction. And for the Y direction we need mode number 3, mode number 7, mode number 11. This one. Okay, I will use these load amplitudes in order to obtain the model contribution of each mode. I will go now to ETABS again, and from define load combinations, add a new combination. I will name this load mode number 1 in the X direction, and here choose the model load case, of course mode number 1, and just copy here the model amplitude to the scale factor, and just copy again the same load case. Now mode number 4 in the X direction, and again copy the model amplitude. And that's all for defining load combination of each mode. I'm just using the first 3 translational mode in each direction. And now we go to display, story response plots. I will select diaphragm of center mass displacement, and from here I will select mode number 1. Just copy this value here to Excel. Here I'm putting the model contribution of story shear in the X direction, and here I'm putting the displacement. Therefore I will copy mode number 1 to here. Now we need mode number 4. And as shown, I'm drawing here the absolute value of mode number 4. And lastly, we need mode number 6. And just in the same way, copy the values to Excel. And of course, we need the final answer or the combined response to check how the modes are contributing to the total response. Now I will need to choose the response spectrum load case, which is this one. As shown here, the black line is the final or the combined response. Therefore, as shown, mode number 1 have the most influence on the total response of displacement. And similarly, I will do it for the story shear in the X direction. I will choose from here story shears. Okay, I have copied all the required information to this Excel as shown here, because it's so boring to show you how I'm copying the information. And here I use the building weight or the effective seismic weight to normalize the shear values as shown here. In the same way, I have normalized the story displacement by building height. Therefore, these figures are unitless, and we can show how each mode is contributing to the total response obtained from response spectrum analysis. And this is the end of this video, and please continue the next one.